Welcome to task 1.3, and we are going to go to page 19 in your packet for our video. It's going to start where it says table and graphs, and if you look in the middle of the page, we've got lots of phrases that we're going to define right now. So let's start with input labels. I'll highlight that yellow. And on a graph, the input label will be down here. That's the horizontal x-axis. And on a table, the input label will be right here. That is the first column. So I am going to say that this is input label on a graph, and it is written on the x-axis of the graph, which once again is the horizontal axis. Goes across. The input label on a table goes right here. So I'll label that correctly. And that is the label on the first column of the table. Now we are also going to talk about the output labels. How about I use purple for the output labels? So the output labels on a graph go all the way on the left, the vertical axis, which is called the y-axis. And on a table, the output labels go as the heading of the second column. So we are going to say output labels are written on the y-axis of the graph, and that is the vertical axis, for those of you who like that terminology. And the output label of a table is the label on the second column of the table. Now, right now, I'm going to try and relate this to some other things. So I'm going to scroll down to starting term number. And remember, the starting term number, which we will put, let's go with green. The starting term number, we asked ourselves the question, when does the scenario start? So remember, it was things like initially, or the first day, things of that nature. So when does the scenario start is what we asked ourselves. So the starting term number is actually the very first x value in the table. The very first x value in the table. So I would say the starting term number is right here. Starting term number. It is the very first x value in the table. So these are the x values that means in this column. And we're going to talk about that next. So you might think that this are the y values in this column, and don't worry, we'll talk about that. But I'm going to highlight this, the starting term number, in green. And now we're also going to talk about the starting value. How about we make the starting value, a color we haven't used yet is red. So the starting value will be red. And remember, what we asked ourselves for the starting value was, what is the starting amount? So what is the starting amount? And we had examples from the previous tasks of 5 dots, or remember that basketball problem was 10 feet was the starting amount. So this is going to be the very first y value in the table. Which means if I scroll up to the table, the very first y value is going to be the starting value, and y values are in the second column, which we'll talk about in a minute. So I labeled that red. So I realize I've got a purple label on the graph that was not labeled, and a purple label on the table that is not labeled. So let me go to purple. It looks like purple was called output values. So let me label this output values. I'm sorry, I forgot to do that initially. And let me label this output values. Glad I'm seeing that now. So now if we scroll, we've got input numbers and output numbers. So let's use blue to label our input numbers. So our input numbers are going to be right here under input label, where the X values are in the table. And in the table, our input numbers are going to be right here, the horizontal axis, where our input label is. So this is going to be input numbers, and this is going to be input numbers. And we will define input numbers in a graph as the numbers used to label the x-axis, the horizontal axis. And input numbers in a table is going to be the list of numbers in the first column of the table. And notice we had already called those numbers the x values right here. So if you want to say x values, I would understand that. And the output, let's go with, have we used red? We have. How about we go with, let's go with this pinkish. Output numbers will be that pinkish color, and they are going to be in a table in the second column. We called that the y values. And in a graph on the vertical axis right here, all the way down to the beginning. Let me do that a little nicer. There we go. So this is going to be called output numbers and output numbers. And we will define this as output numbers in a graph are numbers used to determine the scaling, and we'll talk about scaling down below next, of the y-axis. And output numbers in a table will be the list of numbers in the second column of the table. And earlier we had actually called those the y values, which we can still call them now, right here. So what do we mean by scaling and correct scaling? Well, scaling means evenly spacing the numbers on the two axes. So on the x-axis and on the y-axis. And I'll show you some specific examples on the next page. So the only thing I want to point out is that we did use some examples for starting term number and starting value. So starting term number in green, remember we said initially first day, and we said that that was the first x value. So I am going to say input labels, which were on the x-axis, and the first column, which were the x values, might have labels, for example, that I gave, like days. And output labels goes with starting value. Examples were dots and feet. And we said that was the first y value in the table, the second column. And in a graph, that was the y-axis. So example of labels could be dots or feet. Just to connect that for everybody. All right. Going to the next page, page 20. We've got two examples. How about I try to pick out from the word problems what things that we just talked about are, like the input labels, the output labels, the input numbers, the output numbers, the starting term number, and the starting value. So the number of students who need to pay fees at the bookstore on the first day of school is 150. The number of students who have fees decreases by 15 each week of school. So we have got, and I'm just going to start using any color, not matching the previous page, but we have got the first day, and we have got the number of students who have fees decreases by 15 each week of school. That is a mistake. That should be each day of school. So you can go ahead and correct that typo. And we know one of our units is days. And we also have, if you take a look, we've got the number of students. And we've got the number of students. So we are going to say, let's use green. I like to use green. That the input label is going to be days, and the output label is going to be number of students. And I'm going to attach what we know. We know the number of students who needs to pay fees at the bookstore on the very first day of school. So day one is 150. So there's my first piece of information. I've got the starting term number as 1, and the starting value is 150. Now we know the number of students who have fees decreases by 15 each day. So decreases means to get to the next number, I'm subtracting. That's what decreases means. And I am subtracting by 15 each day. So 150 minus 15 is going to give me 135. So the next day, after day 1 would be day 2, I've got 135 students who need to pay fees at the bookstore. The next day, day 3, I'm going to figure out how many students need to pay fees at the bookstore by, again, subtracting 15. 135 minus 15 is 120. The next day, day 4, I'm going to say there are 105 students who need to pay fees at the bookstore, because finishing this pattern and continuing it, remember, each time 120 minus 15 is 105. And if I continue the pattern one more time for day 5, I will get 105 minus 15 is 90 students. Okay? So remember, please, 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 that the input label was on the x-axis and the output label was on the y-axis. So I am going to say this is days, and this right here is the number of students. And remember, the input numbers just went on the x-axis. So this is pretty easy to scale a number. We're going to count by ones, starting with 0, then 1, then 2, then 3, then 4, then 5. We like to have 5 points on a graph, or 5 numbers in a chart, or in a table, I should say. So there are your input numbers. Your output numbers, remember, they were the numbers used to determine the scaling of the y-axis. Those are the numbers from the list in, let's go with blue, the list in the second column of the table. So these numbers right here, that wasn't blue, that was green. Let's try it again. These numbers right here in blue, they fill in the y-axis of the graph. But I have to start at 0, because that's what I already have labeled, and I have to include 150 in here, either at the top or next to the top. So here's what I'm going to try and figure out. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 lines to deal with. So I am going to take the biggest number I need, which is 150, and I'm just going to go to a calculator and I'm going to say, what's 150 divided by 12? Because that's how many lines I have, and that's 12 and a half. It's real hard to scale a graph with decimals, and I don't necessarily like to use 12 or 13 because I don't know those multiples as much. So I'm going to choose, in this case, to use 15 as my number for each individual line. So I'm going to say this is 0, this is 15, this is 30. 30 plus 15 is 45. 45 plus 15 is 60. 75, I keep continuing, 90, 105, 120, 135, and 150. And I could stop right there because the highest amount is 150. But if you want to put 165, go for it. And now I have done, from the previous page, the correct scaling. Evenly, that's the key word, evenly spacing the numbers on the x-axis and the y-axis. So let me plot some points here. Let's go with purple. I've got 150. So I go 1 to the right, 150 up on my graph. I've got 2 135. I have to graph 3 120. I have to graph 4 105. And I have to graph 590. And I'm done taking my table and turning it into a graph. So does this context represent an arithmetic or geometric sequence? Well, I've got a straight line. So I also have, if you remember, a pattern of subtracting 15 each time. So this supports an arithmetic sequence for both of those reasons. So I will say this is arithmetic because the pattern is subtracting 15 each time. And remember, if we have an arithmetic sequence, we called that pattern a common difference. And I can understand if you're saying each time, we know time is each day. You want to say that, that's fine. You don't have to, though. That's noticing it's arithmetic from the table. From the graph, I see that the graph is a straight line, and that makes it arithmetic just by looking at the graph. So if you take a look at number 2, we'll try to do this one a little quicker. A YouTube channel starts off, so it begins with 17 subscribers, and each day the number of subscribers triples. So it looks like I have days and I have number of subscribers. So I'm already going to say this is days, and this is labeled number of subscribers. I'll change colors to say I start off with 17 subscribers. That's no days. So at day 0, I have 17 subscribers, but each day, so I'm increasing the days by 1. So I'll do 5 rows here, 0, 1, 2, 3, 4. Each day the number of subscribers triples. So doesn't triple mean multiply by 3? So times 3 each time. So I'm going to remind myself I'm multiplying by 3 each time. So 17 times 3 is 51. 51 times 3 is 153. 153 times 3 is 459. And last but not least, I will get what? 1377? So if I were to label these numbers, it's pretty easy to say the days, the x-axis, the input numbers, the scaling 0, 1, 2, 3, 4, but the output numbers, that scaling is a little bit harder to figure out. So I think I have 12 lines I could use again. I have to get up to 1377, so I'll divide 1377 by 12 and get 114.75. How about we use 120 for our scaling? So from 0 to 120, 120 plus 120 is 240, 240 plus 120 is 360, so on and so forth. It gives me 480, 600, 720, 840, 960, 1080, 1200, still not quite there, 1320, and 1440. I will now graph my points. I have 0, 17, that's really tiny. I have 151, that's barely above it. I have 2, 153, which is a little above 120. I have 3, 459, which is a little below 480. And I have 4, 1,377, which is all the way up here. So now I'm going to say that this, in fact, is a geometric sequence. And the reason why is because looking at the table, the pattern is multiplying by 3 each time, or in other words, each day using our labels. And in a geometric sequence, the pattern is called the common ratio. And in looking at the graph, I can tell that this is a geometric sequence because the graph is a curve. So that is section 1.3. We'll see you next time.